Earth is a planet in motion, spinning on its axis as it hurtles through space around the sun. Warmed by the sun's rays, Earth's atmosphere and the oceans are always on the move, while heat from the planet's core keeps the hot rock of the interior constantly churning. All this enables Earth's surface to teem with life. The outermost shell of the Earth is the crust. It is not an unbroken covering, but huge plates of rock that drift over a deep layer of semi-solid rocks called mantle. The oldest parts of the Earth's crust are nearly 4 billion years old. The huge slabs of rock that cover Earth are called tectonic plates. Where the plates meet, they form different kinds of boundary depending on the type of crust they are made and the directions in which they move. The convergent boundary is where two plates collide. In some cases, one plate is pushed under the other. This is called subduction. Divergent boundary is where plates move apart, where molten magma rises from the mantle to fill the gap, building a mid-ocean ridge. And the transform boundaries are formed where the two plates scrape past each other in a sideways motion. Relative to its size, the Earth's crust is thinner than the peel of an apple. Some parts of it are only 5 miles thick. Most earthquake zones are at the edges of the tectonic plates that make up the Earth's crust. When the plates press against each other, the pressure builds until the plates move with a jerk, sending out a shock called a seismic wave. The asteroid impact that wiped out the dinosaurs 65 million years ago may have caused an earthquake of 12.55 magnitude. About 1.3 million earthquakes happen each year, but most are too small to be felt. The strongest earthquakes include that of Valdivia in Chile of May in 1960. This earthquake, measured at 9.5 in magnitude, killed 1,655 people and caused a tsunami that hit Japan, the Philippines, and the US. The 1964 earthquake that hit Prince William Sound in Alaska measured at 9.2 magnitude. While it killed 15 people, it caused a tsunami that killed another 113. The 2004 Indian Ocean earthquake occurred at sea, and this is measured at 9.1 magnitude, and it caused a tsunami that killed 200,000 people and it affected 1.7 million more. The 1952 earthquake of Kamchatka, Russia, and this is measured at 9 magnitude, and it sent a tsunami across the Pacific. In Hawaii, no human lives were lost, but 6 cows died. And there was the 2011 earthquake in Tohoku, Japan. While this was a 9.0 magnitude earthquake, it caused a tsunami that killed more than 15,000 people and destroyed a nuclear power plant. Mountains form over millions of years, thrust up as the tectonic plates of the Earth's crust grind together or crack while moving slowly over its surface. Many of the peaks we describe as mountains are actually volcanoes, active or dormant. The highest known mountain anywhere is Olympus Mons, a volcano on Mars that is nearly 14 miles, about 22 kilometers high. Earth is a slightly squashed ball with a bulge around the equator. Mount Chimborazo in Ecuador sits on this bulge. It is not as high above sea level as Everest, but its summit is farther away from the Earth's center, just over a mile. Earth's crust is made up of plates of rock that fit together like a jigsaw puzzle. Most volcanoes occur where the plates meet, but some erupt in hot spots in the middle of the plates. Between 50 and 70 volcanoes erupt every year, mostly around the edges of the Pacific. Around 20 volcanoes are erupting right now. Molten rock or magma from the Earth's interior may erupt where plates pull apart or force its way to the surface where plates collide. There are around 1,500 known active volcanoes on Earth. The enormous mountain ranges, vast plains, and deep trenches of the ocean floor were created by the constant shifting and colliding of the plates that make up the Earth's crust. Rifts in the ocean floor that form when Earth's tectonic plates meet are called trenches. The deepest places in the ocean and the lowest points on Earth, about 26,000 to 33,000 feet, about 8,000 to 10,000 meters below the surface of the ocean. Mid-ocean ridges are underwater mountain ranges found at the boundary between two divergent tectonic plates. They are all linked, making them the world's longest mountain range at 40,000 miles, about 65,000 kilometers. And seamounts are undersea mountains rising at least 3,300 feet above the seabed. They are volcanoes and many are hotspots of marine life. Flat-topped seamounts are called guyals, and smaller mounts are sea knolls. If Mount Everest were placed on the deepest part of the ocean floor, its summit would still be 7,166 feet underwater. Ocean waters are constantly moving. Their movements, called currents, are driven by wind and the Earth's spin. But ocean currents are also affected by the water's temperature and saltiness, as well as sea depth. It can take up to 1,000 years for ocean currents to carry water from the North Atlantic to the North Pacific. When currents reach the cold polar oceans, some of the seawater freezes. When it does this, it leaves its salt behind. The salt mixes with the remaining water, making it saltier and heavier. This water then sinks towards the ocean floor and drives the currents that flow slowly through the ocean depths. Where these deep water currents flow back up to the surface, scientists call it upwelling. When we are talking about ocean currents, there is still a lot to study, and a cargo of plastic ducks that are lost in the Pacific in 1992 is still helping scientists to learn more about the speed and direction of ocean currents. So far, the ducks have drifted 17,000 miles. Rivers help to shape the earth, wearing down mountains, carving valleys, and depositing soil and rocks to form new land. Lakes hold 20 times more of the planet's fresh water than rivers. Rivers are Earth's most powerful force of erosion, carrying 20 billion tons of land surface to the oceans each year. The Amazon carries 1/5 of all the fresh water emptied into the oceans. A river's size is measured by its discharge, or volume flow rate. This is the amount of water that flows into the sea in a given time. So ranking by discharge, Amazon takes first place, followed by Congo, Chambezi, and the Yangtze River in China. Earth would be peppered with craters like the moon if it weren't for wind, water, and earth-moving crust covering them up or wearing them away. More craters can be seen in old, quiet parts of the Earth's crust, such as in Canada and Australia. An asteroid probably killed off the dinosaurs, but an even bigger impact may have almost wiped out life completely 250 million years ago. Called the Great Dying, this disaster may have been caused by an asteroid impact some scientists think they have discovered under the Antarctic ice sheet. An asteroid or a comet can make such a violent impact that they are destroyed, a crater is left behind, although over millions of years, it can be buried, worn away, and distorted by the Earth's crust moving. On the map are all the largest craters scientists know about. Whether somewhere is hot or cold is mainly to do with how close it is to the equator, but other factors such as ocean currents and altitude are also important. In 1924, the Australian town of Marble Bar reached 100 Fahrenheit or above for 160 days in a row. The Gulf Stream ocean current from the Gulf of Mexico gives Northwest Europe warmer winters than many places farther south. Many deserts are hot during the day but drastically cooler at night. With no clouds or mist in the way of the sun, the ground warms up fast during the day. With no blanketing cloud at night, the heat escapes quickly. The humid climate's daily temperatures vary a lot less. In the middle of large continents, it's often hot in the summer and very cold in the winter. In coastal areas, warm or cool winds and currents carried by the sea moderate temperatures. Without this balance, inland areas can become extremely hot or cold. This map was made by calculating average temperatures throughout the day and night over a whole year. It averages out huge differences in temperature that can occur in some locations, either in a single day or between seasons. You can see clearly that the hottest zones on average are those around the equator. The zones get cooler the nearer they get to the polar regions.